So our project name is Intelligent Biomonitoring Assisting System for Astronaut Spacesuit. As we know that in space there are very harsh conditions that astronauts need to deal with. Astronauts need to make critical decisions, resolve technical failures spontaneously with minimum margin of error. But in such stressful and harsh conditions, it is very difficult for astronauts to do so, and hence it impacts greatly on the success of mission. So we come up with an innovative solution where we are trying to predict set of questionnaires that might arise in the mind of the user in an interval by gathering physical, psychological and environmental data regarding user and his surrounding. Once the questionnaires are generated, they will be fed to the LLM models generated by the space agencies like ISRO and SpaceX, which will be fine-tuned by the space data they have, such as information regarding their spaceships, information regarding the logs of the previous launches on all the things. Now this question will be fed to the LLM model, which will help astronaut in resolving the issue or making the most optimal decision, which will increase the rate of success of the mission. Now let's understand our solution through a scenario. I will explain you how our intelligent system will work in critical situations through a scenario. In 1969, NASA launched Apollo 11 module. It was an automated module which was programmed to land automatically. But during landing, Neil Armstrong noticed that Apollo 11 is landing on a rocky surface, so he decided to manually control the Apollo 11 and landed it on a safe spot. In such situation, risk level is very high and mission failure rate is up to about 60%. So now let's see how our intelligent biomonitoring system would have increased the rate of success. So as Neil Armstrong notices that Apollo 11 is landing on a rocky surface, he has detected error in the landing of the system, which will generate N200 wave in the brain, which indicates that user has detected some kind of error. Now our EEG module will gather these brain waves and predict that Neil Armstrong has detected some kind of error. Now Neil Armstrong goes to control panel to handle the Apollo 11 manually. Now the eye gazing and voice analysis part will run parallelly. Let's say Neil Armstrong says need to find safe spot to land. This will be gathered by the voice analysis module and important keywords like landing spot will be extracted. Now once the Neil Armstrong control the Apollo 11 using control panel, our eye gazing module will capture the environmental data depicting the focus of interest. Now the image captured by the eye gazing module will be fed to the pre-trained model to generate caption which will explain the context of the image. Now all the data captured from the different modules will be fed to a Gen AI model along with other environmental data such as lunar surface images captured by the Apollo's camera. Now this Gen AI module will generate set of questionnaires that may have arisen in the mind of the user along with the probability score for each question. Now this question will be fed to the LLM model generated by the space agencies to answer and assist the astronaut in the most effective and optimal manner. In this way, our system will help working professionals with harsh conditions like astronauts, brain surgeons and many other professionals to make critical decisions and resolve issues with accuracy.